From spinning galaxies to orbiting electrons, science made us explain enormous concepts of the universe and helped us understand the behavior of the tiniest molecules. We should first understand how chemical equations work. This kind of equations represent how a reaction moves from reactants to products by means of either physical or chemical changes. Now here's the thing. According to the law of conservation of mass, matter is neither created nor destroyed. We are only rearranging the position and the orientation of atoms.
If I have pure magnesium on my hand and we set it on fire, it will react with the oxygen in the air, producing an intense white light. Once all of the magnesium was consumed, the end product was a white powder, also known as magnesium oxide. But here's the problem. There are 2 oxygen atoms in our reactant side, yet there's only 1 oxygen in our product side. By adding a coefficient of 2, we will arrive at an equal number of atoms in both sides of the equation.
The limiting reactant in our experiment is magnesium because we could barely run out of oxygen since it's widely available in the air at a very large amount.
We could better understand the limiting and excess reactant if we picture it this way. Let us determine the maximum number of PPEs that can be formed if it will take 1 gown, 2 gloves, and a single mask to create 1 PPE. We must first calculate the number of PPEs each reactant could make by simply multiplying the reactant with the ratio based on our equation. 3 gowns multiplied by 1 PPE having 1 gown, we could make 3. 8 gloves multiplied by 1 PPE having 2 gloves, we could make 4. 5 masks multiplied by 1 PPE having 1 mask, we could make 5. We realize that the highest possible number of PPEs that we can make is 3. The production is limited by the gown, making it the limiting reactant of our experiment. The remaining excess are those we consider as the excess reactant. Now in a hypothetical scenario, let's say we are given moles of magnesium and moles of oxygen gas. We can determine the amount of product that can be formed by first multiplying our moles of magnesium by the ratio of MgO and magnesium. Converting moles to grams, we'll simply multiply our moles of magnesium oxide to our molar mass per 1 mole. We will arrive at our theoretical yield of 4.15 grams of magnesium oxide, which is the maximum possible mass if we were to use all of our limiting reactant, magnesium.
Stoichiometry gives us the ability to create predictions and think of possible outcomes of chemical reaction. We realize how important it is as a fundamental pillar in chemistry and science in general. Its power to explain almost all phenomena of both the natural and the physical world.